Good morning, everyone. Welcome to Dunwoody. We've got a great crowd this morning. My name is David Lyman. I'm a member of the Board of Trustees here, and I'm honored to introduce our speaker today. David Mortenson, chairman of M.A. Mortenson, is a terrific and long friend of mine. And I just have to say a couple things about growing up playing soccer and hockey with David. Dare I say he's a fierce competitor and a great teammate, and we had a lot of fun. So I know David's family quite well. Mortenson is a family company, and it's that kind of spirit and leadership that David brings to Mortenson, which is one of the largest contractors in America. He joined the family business in 1991 and worked his way up by spearheading projects in places like Northern Ireland, Los Angeles, and Seattle. I won't comment on all the community projects that he and his wife Kate do, but they are numerous. They've supported many organizations, and I'm frankly proud of my friend David and all that he's done. They've raised 3 wonderful kids, and those kids have been raised to value legacy and hands-on education. I learned just recently that David's grandfather is a graduate of Dunwoody. When I joined the board, David reached out and said how excited he was. So there are many connections between David, Mortenson, and Dunwoody. I could go on, but I want to end there and ask you to welcome my friend, David Mortenson, to the podium.
Well, it is awesome to be here. I was saying, hang on here. I was saying to Rich earlier, this kind of looks like a construction site at 7 a.m. The parking lot's full, people are pouring in. But it is a huge pleasure to be here because we have been a big supporter of Dunwoody for several decades. And Rich, you and your team do an awesome job of preparing men and women for a career in construction. Not just what's needed to be successful today, but what is needed to be successful tomorrow. And that's what I really want to focus on is what is it going to take to be successful in the 21st century in design and construction. But I first always like to go back and tell a little history. David, you referenced my grandfather, and Mortenson has a great and long and rich tradition in history. And it actually really starts with my great-grandfather. And my great-grandfather, Nels, is the quintessential American story. At age 18, he left Malmö, Sweden, with nothing more than a toolbox and a handful of change. Boarded a ship, crossed the Atlantic, showed up at Ellis Island at age 18, and then, like every great Scandinavian, made a beeline to the frozen tundra. And he honed his craft as a carpenter, as a foreman, as a superintendent, as a field operations manager, and in 1923 found himself running the largest project in the state of Minnesota at the time, the University of Minnesota football stadium, Memorial Stadium. And they did such a great job that, and this, by the way, is back when you built stadiums between seasons. You know, start in November, finish in August, 60,000 seats. They did such a great job, the University of Michigan called and said, hey, can you come build us a big house? And so my great-grandfather loaded up his 3 sons, went to Ann Arbor, Michigan, and told his boys at the time, sons, education this year it's not in the classroom, it's on the job site. And so that was the start of my grandfather's construction career. At 14, building the big house, and that bowl still stands today as a testament to great Scandinavian hard work. And he followed his father as a carpenter, as a superintendent, as a field operations manager, and then started the company in 1954. That's 65 years ago. And while his focus was really just starting a company that could serve the customers that he knew here in the marketplace, it was really my dad who had a bigger, broader vision of creating an organization that could build its capabilities and its capacities year over year over year, providing a platform for people to take us places that we could not have imagined possible. And today, let's see, make sure I can get this headed in the right direction. There we go. Today, in 2019, we'll be over $5 billion organization with nearly 7,000 people working across the country. And that's about 4,000 people in the field, men and women in our craft, everything from electricians to millwrights, from carpenters to laborers, and about 3,000 professional salaried staff. And when I get a chance to speak around the country, people always want to know two things about Mortenson. We're the #1 sports builder in the country. That actually started when we built Target Center here in Minneapolis. But we just completed and turned over the new Golden State arena, I refer to as Steph's Palace. We're building the new Las Vegas football stadium, which will rival US Bank Stadium as everyone's favorite NFL stadium. And I say rival, but it won't surpass. But then the other thing people always want to know is, tell me about what Mortenson is doing in the renewable energy business. We set our first wind turbine in 1994 and have been a leader in this industry for the last almost 3 decades, and are currently the largest design builder of both solar and wind in America. We'll install over $1 billion worth of wind energy this year. And those two are just 2 of our 16 business units. And some of them are geographically based, like here in Minneapolis or in Denver or Seattle, and then some of them are industry specific, like wind and solar and sports and battery storage and high voltage transmission. And people want to know, so how did you get into so many places? How did you decide and seem to have such a great view of where the future was going to take you? And I always think it's our job as leaders to create vision and then to enable. It wasn't the people on the 4th floor back at the home office that decided we should get into high voltage transmission or battery storage. It was Mortenson people close to the customer and close to the work that decided, hey, I think we could do this. And our job as leaders is to enable that pathway. And when we talk about building in the 21st century, this is about creating pathways to the future and enabling team members to envision what might be possible. We are at a super cool time. We are in the 4th industrial revolution. Thomas Friedman, the Pulitzer Prize winning New York Times columnist, says this industrial revolution is so big, we should just call it the supernova. And we are in the middle of it. And it's hard to recognize a revolution at the very beginning. If you think about the industrial revolutions that we've been through, the steam engine was invented in the early 1700s. And it really got going in the 1800s. And for the next 100 years, the Industrial Revolution was defined by steam power, all the way up until just before World War I. And suddenly, the internal combustion engine and electricity then became the driver of global economic growth. And really, for the next 50 years, those two things, electricity and the internal combustion engine, drove the second industrial revolution. And then by the 90s, the fact that the integrated circuit had been invented in the late 50s, Moore's law started to become applied, and computers became something that we all found on our desks, the third industrial revolution started. And for the next 30 years, our global economy has been defined by the computer and the telecom revolution. And today, we sit at the beginning of the supernova. And you can see the industrial revolutions, 100 years, 50 years, 30 years, they are moving faster and creating more than anything we've seen in the past. And the fact that we now have ubiquitous, cheap computing power at the fingertips of anyone who wants it. It used to be you had to go to Livermore Labs in California to get access to a supercomputer. You can buy an hour of supercomputing for less than $25 today. And that, combined with the fact that software applications are being built and developed more quickly than at any other time, those two things are they're changing industries, and they're going to change our industry. And we're starting to see it. And why is our industry ripe for absolute disruption? It's because we have not changed in a long, long time. This is a productivity curve. The top is the change in manufacturing productivity over the last 3 to 4 decades. The bottom is the productivity change in design and construction. I mean, that's negative productivity change. In a world where everything has to be faster, cheaper, and better, the construction industry has done none of those three things. We've stayed the same. And that's about ready to change, because the supernova is starting to impact us. And you're going to hear this term, the industrialization of design and construction. And we're starting to see the disruptors arrive. And these disruptors are being fueled for the first time by enormous amounts of venture capital flowing into our industry. Companies like Katera, who, if you went to their website, while they build apartment buildings and limited service hotels, they don't define themselves as a design company or construction company. They define themselves as a technology company. And what they have figured out is that design and construction is largely designing, procuring, logistics, and installation. And they've taken a group of leaders from Foxconn, who is the manufacturer of the Apple iPhone, and they've said, we can revolutionize the value chain in design and construction. And they are promising their customers to produce apartment buildings 20% less than anyone else in the marketplace. Guess how much they've been funded by SoftBank and the rest of the venture capital world? $1.4 billion to disrupt our industry. And Amazon now is in the prefabrication business. They're actually investing in companies that are prefabricating homes. WeWork, Google, Factory OS. The disruptors are at our doorstep, and they're not coming from our competitors. They're coming from outside of our industry, and they're leveraging computer technology and capability to change process. And that's, they've gone to what, I think our industry has always asked our customers what we could do better, but the disruptors look back and look at what Henry Ford said, which was, hey, if I'd asked my customers what they needed, they would have said a faster horse. The people that are going to transform the industry aren't looking at a faster horse. They're reinventing the design and construction machine. A number of megatrends are already underway and have been for the last 10 or 20 years. Certainly the digitalization of design. If you walk to a Mortenson construction site today, you would not see a plan table and a roll of drawings anymore. Our foremen are working off iPads. Our integrated construction coordinators are helping combine mechanical, electrical information into just what our craft people need right at the right time. It's making our people more productive. It is not yet having an impact on the time, cost, and quality of what we're producing. Because all we've done is we've taken the way we used to do it, hand drawings, spreadsheets, and we've put it in the digital realm. People like Autodesk are starting to say, if we develop a software and we use computing power, we can start to change design. Generative design and artificial intelligence
we've created tools that have in turn
part of our
helped us
future.
create our world. And while those tools have made more and more things possible, they've also defined our aesthetic and limited our imaginations. Until now, if you couldn't draw it, you couldn't fully imagine it. But what if instead of drawing what you already know, you could tell the computer what you want to accomplish? For example, say I want to design a chair. Instead of drawing a chair and then playing with the form, I could instead tell the computer that I wanted a chair that can support this much weight, weigh this much, and cost this much, and produce something based on the material that I've chosen. The computer can then deliver to me thousands, if not millions of design options, all of which meet those criteria. And from those options, I can pick the one design that delivers on the most important criteria. And the one that I select might not even been one that I could have imagined on my own. That's the promise of generative design. But why is it important? It's an entirely new way of doing things, and the benefits are potentially staggering. Unprecedented reductions in costs, development time, material consumption. The sky's the limit. And when we combine generative design with the emergence of new forms of manufacturing like 3D printing, we suddenly have access. Traditional manufacturing methods require you to make massive numbers of something just in order to be profitable. Small designers without access to production resources were simply out of luck. But now we can do a batch run of just one. The stage is being set for the reemergence of local manufacturing. Generative design extends beyond manufacturing. In fact, everything that's designed will be affected, including the built environment. How do you create an ideal floor plan? Can we balance structures for material type, strength, and energy consumption? Generative design promises a way to answer these questions and to create designs that avoid waste and control cost. So all that's great. What does this mean for the designer? Now they will co-create with the technology, choosing the constraints and setting the goals. The software simply determines the most optimized way of achieving those goals. It's going to lead to astounding results. And that's generative design.
And this isn't just wishful thinking. This is happening today. If you'd asked me a couple years ago, would we have computer scientists working in our design group, I wouldn't have thought that was possible. But today we actually have computer scientists in our WIN group developing algorithms to help us design more effective and efficient layouts for the civil and electrical infrastructure on our wind projects. Just think, it used to be smart engineers sitting around the table working through simulations and thinking about scenarios. Today, we're running scenarios and simulations, 1 million possibilities overnight. So we can totally optimize. And in our wind builder, we went back and we looked at about a dozen projects that we had designed previously, and we could have saved anywhere between 1% and 5% if we had run those old projects through our optimizer, all based on computer capacity and software. But those tools are just getting going, as are other tools like robotics. I mean, we've got excavators on our projects today that are being remotely controlled. If you got in a D9 Caterpillar, a big, huge bulldozer today, you would feel like you were in the cockpit of an airplane because it is computer driven. And in fact, kind of like a pilot on autopilot between takeoff and landing, that operator today is managing a computerized system, not pulling the levers of the blade scope anymore. It's being driven by GPS, software, and computing power that's going right from the model to the machine. And we're starting to change what we do on our job sites, how we inspect, our ability to use both augmented reality and virtual reality.
At a stage that's one of the most complex stages in the project. We've coordinated it, concrete's up, the structure's up. So we're at the point where now we're really just getting going, putting all of our MEP work in place. And of all projects, a hospital project is one of the most complex when it comes to putting MEP work in place. So by looking at the helmet today and seeing those scopes in the context of where they were going in, it was really interesting to see what was installed and what's going to be installed tomorrow, from electrical to plumbing to ductwork.
What I saw was I was in awe. It was pretty cool. It was surprising how real it was, in the same sense of being able to see in the future, right? So instead of just being in the virtual reality world and you're sort of stuck in far off land, right? You can actually see the walls, you can walk the job site, you can actually see what's in real life at that present time, look up, and you can see the future.
This technology will change my job by making it another tool for us to communicate our efforts of modeling and coordination with other people, both installing and quality assurance and quality control aspect of the job.
Well, the biggest problem that we run into is just the coordination effort. You know, everybody's trying to get as much components and their equipment into a small, limited space. So anytime that you can bring tools such as the daiquiri helmet to allow you to see that stuff would be a benefit.
I think it's going to help out the MEP immensely, simply because the fact is they're going to be able to see a lot of the collisions that are above ceilings and situations that fall within the walls. So I think that's going to help them immensely as far as getting ahead of the program, getting ahead, catch those issues early.
It has the potential to answer a lot of the questions and issues that we have. And a lot of that's around digitization, right? So we've digitized all of the information we consume in the field. We've digitized the capturing of information. What we haven't yet done is taken that digital information and put it right in front of the people in the field. So in using the helmet today, I think that's where the real potential is. It allows you to see issues that might arise in context of where they're actually going to be installed. I think in the end, it'll help us, you know, as a builder to head off a lot of those issues that potentially come out on projects.
This is just the beginning. I think we're going to see more and more of this stuff. I can see coordination meetings, instead of sitting behind a computer, being on a job site with helmets on. I see us using this technology to look in the future, both on the construction side and in the office when we're designing and modeling the components.
Yeah, to physically be out there in the field and put two and two together, it helps out.
It gets pretty exciting when you start to think about the IoT boom and having a lot of connected sensors, information on the job site that we don't have today. How is that going to connect into something so that you can see that when you're out in the job site? It's all great in the trailer.
So we've got generative design, AI, digitalization. We're being able to take these tools and visualize them right on the job site. But the question is really how are we going to take all of this capacity and change the value chain to actually make a difference in the cost, schedule, and quality of the facilities that we desire. And this is about where the industry needs to go to compete with the Amazons of the world. By the way, if you wanted, you can go on Amazon.com right now today, and you can buy a tiny house that sleeps 6 for $125,000, and they'll deliver it in 5 weeks. Okay, so if you don't think they see an opportunity in our industry, and if you don't think that they've got technology and logistics figured out, they're the disruptors and the new competitors that are going to start entering our marketplace. So what do we need to do to prepare for that future, to be able to deliver on that same promise? And it starts with the digital model. One simple integrated place where all the information can exist. You would think in the 21st century this would already exist. It does not. Our lighting sub-consultants still design in 2D. And we've got a computer tech who's taking that 2D information and trying to put it in the model and figure out the conflicts and send it back to the lighting designer so they can revise their 2D documents. In fact, we're doing 350 projects around the country. We only have 3 or 4 projects where the designer gives us a model that we can rely on. That's actually a contract document with dimensions and information that everyone can rely on. We still go back to our old structure of 2D drawings and our contract. And how we use the model to integrate, to change process is the fundamental key. And we need to do 3 big things. And a totally integrated model and a more integrated supply chain will allow us to prefabricate and manufacture more work off-site. That's the start. Just think, is the most productive, safe way to build is have a plumber on a 12-foot ladder welding a piece of copper pipe? I mean, that's crazy in the outdoors. Why we can't build more off-site, delivered just in time. And the problem is we've got to develop a supply chain and partners that enable this to happen. And we've got to build this into the process of design at the front end. You can't decide after the design is done that you want to manufacture your bathrooms off-site. You have to start with that concept in mind. And we're so used to custom designing everything. We did a hospital job in Denver, 450-room hospital project, and we decided we wanted to implement off-site pre-manufactured bathrooms. When we analyzed the design, they had designed 57 different bathrooms for 450 rooms. That's not very efficient. By the time we went through standardization, we got that 57 down to 8. Then we could prefabricate off-site. And we've got to be trying and experimenting with this on every single project we do so we can build the supply chain and build our capabilities. Here's a great example of maybe the ultimate prefabrication. This is a hotel in Seattle. And these rooms are being built in Poland, shipped to the job site And then the room, complete with bed sheets, is being delivered onto the job site and bolted into place. So we're delivering probably
Work has been progressing on the procurement improvement.
We're delivering that hotel about 30% faster than what would be possible with traditional. And we have our second Citizen M hotel in Los Angeles just under construction now. And what Citizen M has decided is that when people stay in a hotel room, they mostly just go to their room to sleep. So they've shrunk the room and they've invested in the common spaces. And they've decided along with us that when we shrink the room and we can make the room about the size of a container, we can build the entire room off-site. And our LA project now, our supply chain is actually in Asia, and those containers will start shipping in about 120 days. So we've got to use this digital information. We've got to change our supply chain, and we've just got to fundamentally change what we're doing. We still, with all of these awesome tools, our standard process when we design a bathroom, and we can put people in that virtual reality set of goggles, and our customers can see exactly what that operating room's going to look like, and they can choose the tile and the cabinetry. And then after they do all that cool stuff in the 3D helmet, we call the architect and we tell them what sink and what tile, and the architect puts it in the specifications, and then they PDF it back to us, and then we email it out to our suppliers, and then we wait 4 weeks for bids, and then we go through 3 weeks of contract negotiation, and then we wait for their bond and insurance, and sometimes months later, we've actually ordered the toilets. It's crazy. We've got to get to one click. We live in a one-click world. Make a decision, one click, it's ordered and tied to the schedule. And this is a little experiment that we've been doing with Kohler about how do we get to one click.
Work has been progressing on the procurement improvement prototype. Phase 2 has been all about applying the concepts and work from Phase 1 to a real project and seeing what complexities develop. The Hilton Garden Inn Madison project was selected to be our test project, and we built out the 6 different guest room types in VR. Between the 6 rooms, there were 13 fixture assemblies with 38,880,000 possible unique configurations that had to be selected and confirmed for ordering. Once an assembly is selected, the report dashboard updates showing cost and lead time information for that assembly along with the tools for the entire project. When all items are confirmed, the ability to click order is unlocked. This exports a machine-readable bill of materials that can be sent to a purchasing system electronically.
So that's the start of one click. You can see the complexity, right? 3 million different scenarios and options. And we still have our customers who are in a framework of, well, I'm used to seeing 5 or 6 different bids for the toilets. Well, can you imagine how much money we spend to try and prove out whether we're saving $1,000 or $2,000? We've got to make this leap into the 21st century and say, this process is going to be faster, and time is more important when you're thinking about dollars than any other single factor. We have a long way to go, And the winners in the 21st century are going to be those that are the tri-stormers. And I like to say in our organization, I don't want any more brainstorming. Brainstorming is where good ideas go to die in a conference room. We need tri-stormers who are going to decide that they're going to go out and try to make something happen, knowing that they're going to fail, knowing that it's not going to work the first time they do it, but committed to a better way to redefining what's possible. And then the last bastion for the 21st century is going to be able to take all this wealth of data and information and change our analytics from energy to cost to schedule to help us be able to redefine those algorithms that we put back into our generative design process to actually create better answers and better solutions for our customers. So I love speaking in front of a group of energetic students because it's you here in the room that are going to be the ones that get to redefine the direction of the industry. It's not us older guys who are going to be the tri-stormers reinventing how to get to one click. You get to change the value stream and deliver on this promise that we can deliver faster, better, more cost-effective facility solutions. And that's what's cool about our industry. You are at the doorstep of the revolution, and you get to define where it's going. So thank you very much, and I'll take any questions you have. Awesome.
One of the things we need with our students, as you talked about, is hands-on doing the work.
Yeah.
We need companies to help give us projects that we can use to train our students to do the things you need in the future, to help do that trying so we can figure out what to go.
Cool. You could be part of our one-click tri-storming, it sounds like.
That's exactly what I'd like my students here to learn.
Right.
So right now I teach them from a book, and it's far better to teach them on a business site if I can.
Count us in.
Thank you.
That was easy.
Who else? Anybody else got something they're thinking about? Oh, I'm sorry. Go ahead, Ted.
David, Ted Ferrera. Your industry is heavily regulated for safety by different agencies and construction codes.
Yeah.
How have you found that element of the industry when it comes to some of these innovative construction techniques? Are they inhibiting, helping, and how do you deal with it?
The question is really around regulation in a highly regulated industry. How are these tools and those regulations either inhibiting our ability to move to the 21st century or enabling? And I'd say the single biggest thing is getting through the permitting process. Our permitting agencies live in a two-dimensional world, and they need to change also. And they can change with better information. I mean, we can run fire simulations. They don't actually have to just guess at where the exit should be or the smoke detectors or how much smoke a exhaust fan can remove from a building. We can actually run a 3D simulation. But how often do we submit a 3D simulation as part of our code compliance? Rarely. And so we need to partner with our code folks to help them be ready for the tools of the 21st century. That's the biggest inhibitor, because they're forcing us right now to live in two worlds, both 2D and 3D.
Greg, did you have a question?
Yeah, I did. Greg Stefransky, and really a great presentation. My question is, as you think about your workforce and the changing skills mix it's going to take to drive all of this, could you describe a little bit about how fast it's changing, what the big changes are, and for a room like this, what we'd expect to see the changing demands in the near future?
Well, give you some context. In 2006, between 2006 and 2009, the industry lost about 3 million people. And we'd already been on a sliding decrease of skill in the workforce. And we've got a tight labor market today with all of the work going on. And so tight labor market, decreasing skill, we actually need to make it easier for the people in the field to install. When we custom build everything one piece at a time in the field, that takes a lot of craftsmanship. So these pieces and parts of creating subassemblies off-site and bolting them in place actually are going to be part of the solution that we see in this very tight current labor market.
One over here.
David, great presentation. It's exciting. How does this affect the number of employees? Do we eliminate people?
Right. So how does all this technology affect the number of employees? I mean, that's a question that's being asked across multiple industries, not just our own. And what I'd say is the skill sets and what we're going to be doing are changing. And yes, we should be more productive, and one person should be able to do more. But what our project engineer is doing on the job site today is mostly answering questions, processing shop drawings, and then checking QA/QC. We don't spend very much time on our job sites today figuring out how to build the building better or faster or more cost effectively. We're just still trying to figure out what we're going to build. And so I think what we see is this shift, and it's same with generative design. Designers aren't going away, they're just partnering with the computer. You still have to have somebody who's going to put all the context of what the needs are in order to define what the outcome wants to be.
Anybody else we have time for another question if somebody has one? Up all the way back there, and then we'll come up here.
Derek Gilson in the facility program here at Dunwoody. Can you talk about how you're integrating ownership and operability into your process to make owners have the benefits long term?
Yeah. So the question is, how do we take both the design and construction process and integrate it into operations so we can better leverage the long-term cost of a facility and make better decisions on the front end. And we have more data today and more tools enable us to do that. We also find our customers' systems are broken. They have a capital allocation process, and they have an operations cost process, and those two things are often disconnected. And in the design process, we need to reconnect them so we can help them focus on what the long-term cost and benefit is. And the tools that are starting to emerge that allow us to better leverage energy solutions, better allow us to have more cost-effective maintenance solutions are just starting to be leveraged. It's part of, I think, what's going to be exciting that you're going to see change a lot in the next 5 years.
We have time for one more. There's a hand right here, so let's go right there.
Ryan Rodemacher, great presentation, thank you. So my question is centered around, basically I hear there's sort of 4 people involved in 4 groups, right? You have design, construction, manufacturing, and now technology-based companies sort of disrupting and turning into the fold. Design and construction is a one-off endeavor. Most of the other endeavors that technology is doing is a sort of multiple product and mass producing. So how do you apply sort of a mass customization to something that is really a one-off world?
Yeah. This idea, and manufacturers talk about mass customization a lot, and I believe we need to find ourselves, we need to migrate ourselves from mass customization to more standardization. Manufacturers started with mass production and then got good at mass production and are moving to mass customization. And we've got to find ourselves somewhere in the middle. And right now, we don't standardize anything because we can reinvent everything every time we go to a new job site. The emergency stairwells that nobody goes in unless there's a fire, they're custom designed on every single project. That's crazy. Even elevators and elevator shafts, there's very little customization in terms of size and capacity, and there needs to be more for us to benefit from the efficiencies of off-site, and that's going to take a while.
Part 2 to the question. Who's leading this transformation right now of those 4 groups, and is that the right group, or should somebody else do it?
Who's leading this revolution? At the front of a revolution, I don't think you have the answer to that. We can see the disruptors in technology. We can see the experimenters like Autodesk on the design side pushing generative design. We can see some of our supply chain shifting to producing more off-site solutions. We're trying to be the ones in the middle and be the total integrator. We've started a manufacturing business. We're off-site manufacturing. We've started a supply chain and logistics business. We've got 45 full-time electrical engineers. We've started an engineering business because we're trying to figure out how to integrate across all those capabilities. I don't think we have the answer to who's going to win yet.
We want to be sensitive to people's time. I know there were a couple of hands that were up yet. David, maybe you can
I'll hang around.
Take questions for those of you that had your hands up yet. Well, how about another round of applause and thank you. Today. That will go back to our normal first Thursday, so that'll be Thursday, November 7th. Please join us. We look forward to a great presentation. And secondly, for those of you that are going to be leaving the campus, there are road closures with the rally tonight. We have maps available to you if you're heading back into town, just to help you navigate the area. Thank you all for being here. What a great message. What an exciting time to be in education as we see all these changes coming through all of our programs. It's great to see how industry, a local industry, is leading that change.
And we hire 300 interns every year, so www.mortenson.com.
Thank you, David.
Thank you.
Everybody.